Imagine a world where the atom was considered the smallest, indivisible building block of matter. Unbreakable. Unchangeable. Scientists believed they could create heavier elements by bombarding atoms, but never shatter them into lighter ones. It was a fundamental rule of physics. But what if, in the depths of December 1938, a baffling discovery in a Berlin laboratory shattered that belief? A discovery so impossible, it defied all logic, yet held the key to unlocking the most powerful force known to humanity. Our story takes us to Berlin in the late 1930s. The scientific world was racing to create transuranic elements, new elements heavier than uranium. By firing neutrons at uranium, they hoped to add particles to its nucleus, making it heavier. Leading this charge was a brilliant team. Otto Hahn, a meticulous radiochemist. Fritz, his skilled analytical chemist, and, crucially, Lise Meitner, a theoretical physicist of unparalleled insight. But the political climate was darkening. Lise Meitner, an Austrian Jew, was forced to flee Germany in July 1938 as Nazi persecution intensified. It was a devastating loss for the team. But Hahn and Strassmann continued their experiments, corresponding with Meitner by letter, never suspecting what they were about to find. After bombarding uranium with neutrons, Hahn and Strassmann expected to find more heavy elements, or maybe radium, which is close to uranium, on the periodic table. But after weeks of meticulous chemical analysis, they found something utterly baffling. Among their reaction products, they consistently detected barium. Now, barium is a much lighter element than uranium, roughly half its size. It was like shooting a cannonball at a brick wall and finding only half bricks but from a different kind of brick. Hahn, a brilliant chemist, was sure of his results. His chemistry was impeccable. Yet, the physics seemed impossible. How could bombarding uranium with a tiny neutron turn it into barium? In a letter to Meitner, Hahn wrote, "We know that it can't really burst apart." He was describing something no one believed was possible. While Hahn and Strassmann published their chemical findings, it was Lise Meitner, now in exile in Sweden, who provided the astonishing theoretical explanation. Over the Christmas holidays of 1938, walking in the snow with her nephew, physicist Otto Fritz, read Hahn's letter. They had a eureka moment. Meitner realized that the uranium nucleus, instead of adding particles, had actually split in two, like a liquid drop breaking apart. It had fragmented into lighter elements, specifically barium and krypton. She calculated the immense amount of energy that would be released in this process using Einstein's famous E=mc equation. Frisch quickly coined the term fission, borrowing from biology, where a cell divides. This was the first time anyone had understood that the atom could be split, releasing incredible amounts of energy. The world quickly grasped the immense power of fission. This discovery, made just months before the outbreak of World War II, immediately raised fears of atomic weapons, leading directly to the Manhattan Project. Yet, fission also gave us a new form of energy. Today, nuclear power plants provide a significant portion of the world's electricity. The story is also tinged with injustice. Otto Hahn alone received the Nobel Prize, a decision that unfairly overlooked Lise Meitner's absolutely critical contribution. December of 1938 stands as a watershed moment. A chemical puzzle became the first clue to breaking the unbreakable atom, unleashing a power that reshaped our world. If you're fascinated by the deep mysteries of science and the groundbreaking discoveries that changed history, hit that subscribe button right now and join the Feed Your Mind community. We unravel the biggest questions. Your next discovery awaits.